Here I give you, if you compare this handout with previous handouts, I give you different ways of solving systems of equations. Again, we have a 2-by-2 system. Another way of solving this system is using Cramer's rule. By the way, we already discussed Cramer's rule in section 2.4. This is how we jump from this system to these formulas. Let me remind you the Cramer's rule. By the way, we can apply Cramer's rule only if we have same number of equations as variables and if the determinant of the matrix of our system is not equal to 0. We can apply Cramer's rule not only for 2-by-2 systems, but to 3-by-3 and so on. Here's how it works. Denominator each time is determinant of matrix A. Here, determinant of matrix A. Here, determinant of matrix A. In order to come up with a top, for x1, we replace column number 1 by 1, -7. For x2, we replace column number 2 by 1, -7. And the result follows. Same approach works if we have 3-by-3 and so on. Think about questions.
For the example you just showed, Cramer's rule,
Yes.
Which matrix are you referring to?
Matrix A, we call it the matrix of the system is 1, -2, 3, 4. This is matrix A. And therefore, here and here, we have its determinant.
Okay.
Other questions?
Professor, I know this was explained previously, but
Yeah.
Where do the top numerator values for the x1 and x2, where do those come from?
How we come up with the top? Yes. So we have two variables, x1 and x2. Each time denominator is same. But how do we find top? In order to find top for x1, here we replace column number 1 by 1, -7. Here for x2, we replace column number 2 for 1, -7.
Okay.
That makes sense.
Yes.
And same for 3-by-3, 4-by-4, and so on. We'll play.
And I assume the theory for why that works is
Again, not
pretty
so easy to
convoluted.
explain. No.
Of course.
It's not easy.